Hello, everyone. The purpose of this recording is to give a brief demonstration about Domain AI, a platform that's focusing on an AI-powered knowledge base that's been in development at Tricension for the previous tenure. Initially, I'll give you guys a walkthrough over what Domain AI is and what it means. Essentially, Domain AI is a tool that collects your own data, that collects your knowledge base, and ingests it into an AI engine. And then that AI engine then transforms that information into something that's readily usable by your organization. To give a brief background on to what the application and what the features of the applications are, we'll move on to our next slide. So here you can see that the application is split into multiple portions. The major portion of the application is data ingestion, where the most portion of your organization's data is going to come in. Right now, we support data ingestion in multiple ways. You can upload CSV files, you can upload text files, PDFs, Word files, in addition to sitemaps. What that enables is that it gives you multiple input streams where you can take any sort of data that's scattered around throughout your organization and then readily ingest it into Domain AI. In addition to these sources, Domain AI also allows the capability to ingest data from databases, readily connecting to your already existing databases in your organization. Those then get powered to our AI engine, and then that AI engine, which uses Azure Cognitive Search and Azure Cognitive Services, return that data to our web-based application. So Domain AI also allows users not only to just use their own web portal, but also have access to open APIs to which they can hook Domain AI into their own solution or their own platform. And also Domain AI also allows users to integrate with Zapier. Now, some of the key features of Domain AI are role-level security, essentially allowing people with a specific role to have access to specific information. For example, if you have someone in accounting and someone in HR, and you don't want the HR person to have access to accounting data, which is sensitive, you can just limit that data through assigning specific roles. Now, Domain AI also has four major features in addition to that. One is our instruction management, our prompt management, and also our multi-tenant application architecture. Now, Faizan will introduce the next portion of the application, which is our .NET app portion, which is essentially our middleware of the application. Take it away, Faizan.
Yeah, the domain AI middleware is developed in .NET 6, and the reason for developing .NET on .NET 6 is to cater the enterprise level features like multi-tenancy, row level security, data security features, and seamless data ingestions. And the other tools involved in the middleware creations are Entity Framework, Link, SQL Server, Microsoft Power Automate for ingestion flows, Azure Blob Storage for storage containers, and this application generally follows the green architecture pattern for improvised performance. Like I would like to introduce the Python guy for this project, and that is the developer of the main Python engine, Asad Edge. Asad, please proceed.
Hello, everyone. So I will be explaining the architecture of AI engine associated with domain AI. The architecture basically comprises of, let me just tell you the tools initially, what tools were used to create this Python engine or the AI engine. Uh, First of all, we use the Python 3.9, Flask, Flask 2.3.2, Azure Blob Storage, LangChain, Azure Cognitive Search, and OpenAI LLM. So the engine itself comprises of two main parts, indexer and information retriever. The engine is entirely made using Python 3.9. It is a web API platform that serves requests from the middle tier of the domain AI to process the text extraction from documents uploaded by the user and also for responding the queries of the user. Flask is used for building the web APIs for the AI engine of DomainAI. Let's go to the indexer. For the indexer part, the main tool being used in the LangChain is the LangChain platform for Python, which enables us to extract the data from different kinds of data sources. It's important to mention that LangChain is not entirely utilized, but the functionalities are overridden and modified as per the need of the application. The indexer contains different sorts of data loaders for different type of documents. Let's start with the data flow for the indexer. The primary data source for document retrieval is Azure Blob Storage. Once the documents are uploaded by the user in DomainAI, they get stored in a blob container. Middle tier application of the DomainAI tells the engine about the container to retrieve documents uh, from the blob storage, and uh, also it allows you to actually expect the data within the indexer. Once a request is received in the indexer, the engine checks for the type document in order to decide which data loader is most suitable for the extraction of data from the document. Once decided, it goes into the specific data loader as per the extension of the document that was sent along with the name of the document. These are the document loaders currently available in the AI engine that are Azure CSV Loader, Azure PDF Loader, Azure Blob Storage File Loader. These document loaders take the container name, connection string, and file name and retrieve the document from Azure Blob Storage. Once the document is retrieved, loader now loads all the text extracted from the document and create chunks of the data with a chunk size of 2000 using recursive character text exploiter provided by LangChain. Chunking is necessary due to the token limit of OpenAI LLM. Once the entire document is chunked, all the chunks are sent to OpenAI to create embeddings for every chunk of the document. It is necessary to create embeddings because it is used for effective information retrieval from the indexes. Now, the document chunks and embeddings all are sent to Azure Cognitive Search Index and stored there for later retrieval. Indexes are created using segment names provided by the user. They are automatically created if not previously available. Otherwise, the information gets indexed into the same segment. In case of a URL or a sitemap, AI engine contains sitemap loader or URL loader. These loaders do not go to Azure Blob Storage. Rather, when a request is received for a URL or sitemap, it will need to have a URL, which will then be validated, and then these loaders scrap the web page or entire website in case of a sitemap. Once the data is loaded by the loader, remaining process is same for chunking, embedding, and indexing of the data. And the data is then saved to the specified index. For the database part, no retrieval or chunking or embedding is required. Instead, the database is configured using the connection string and some relatively frequent queries used by the administrator of the database. A training dataset is created using those frequently used queries and is saved in DomainAI for retrieval of data in the later stages. Now let's go to the second part, that is the information retriever. This is the part where user queries gets answered. This query is first validated against all the available segments. A specially trained model is doing the validation job. Once the validation part completes, there are two possibilities: segment unidentified and segment identified. In the case of segment is unidentified, sorry, if the segment is not identified and the query belongs to a general context rather than belonging to any provided segment of the user, it is immediately sent to OpenAI LLM model to get answered from their own knowledge base. In the second case, if a segment is identified, the identified segment name is sent to the middle tier of the domain AI, where it decides based on the configuration of the segment where this query needs to be redirected in AI engine. Now again, we have two steps. Either The segment is a type of document, sitemap, or a URL, or either the document type or the type of the segment might be a database. So in the case of document, sitemap, or URL where we created indexes, the first flow is if a segment belongs to any of these categories, document, sitemap, or URL, the middle tier sends it in the request to retrieve information from the indexes, user's own knowledge base. The request comes in with the query and the segment name. User query is processed and also gets converted into an embedding using OpenAI embeddings. The query and its embeddings are then sent to Azure Search along with the segment name. Azure Search looks for the desired index in its collection using the segment name provided. Once an index is found, the embeddings of the query and the data available in the index are weighed with the document embeddings available in the index. Top 5, 10, or 50, depending on the chunk size, nearly weighed chunks are then returned from Azure Search to the AI engine of DomainAI. This bunch of chunks is passed to conservational retrieval chain of LangChain along with the user query, which then sends a request to OpenAI LLM to answer the query according to the available chunks and provide a final answer. This final answer is then returned to the user after answering their query from their own knowledge base. The second case for the database. If a segment is a database segment, in that case, the request coming in will contain the user query, database connection string, and training dataset which was created in the indexer part of the AI engine using the frequently used queries. The AI engine sends the user query along with the training dataset to OpenAI LLM, which in return provides a suitable and runnable SQL query to the AI engine. The query is then sent to the database using the database connection string. A value returned from the database is then again sent to OpenAI LLM to use that value as the answer for the user query, and respond in a natural way. So that's the entire flow of the application. Uh, and that's it from my side.